education and training using numerous real-time 3D technologies and techniques for the corporate, industrial, military, and now energy sectors. Mike continually strives to provide the best level of service and custom-end solutions to the clients and their end users while enhancing many aspects of their product or service lifecycle. From concept and product launch through operations, maintenance, and technical support, real-time 3D or game-based technologies can benefit any company in countless ways. Please welcome Mr. Mike Clerk.
So today we've got two panelists. We were having three. Westinghouse, unfortunately, due to some other requirements, was not able to attend. I'll present a little bit of what they're doing in terms of energy and game-based training. Who we do have with us is Williams Van Hedderbeck, sorry for the laryngitis. Williams Van Hedderbeck from Total. And so he's located in Paris. He's one of the founders of Digital Innovation Department, created in 2006 at Total Corporate Division. Since then, he has strongly promoted the benefits of 3D within Total in terms of refinery chemical plants and E&P assets, and developed new training concepts with 3D simulations. So please welcome Williams Van Hedderbeck. Our other panelist today is Ray Rice, who will be presenting and discussing their efforts to develop cross-platform virtual maintenance training, 3D interactive technical manuals, and interactive multimedia instruction for the solar industry. So please welcome Ray Rice. So right now in the energy industry, it's very much like the military industry was about 10 years ago. With the exception of the early adopters, a lot of the energy industry doesn't know what game-based technology is or how it can benefit the corporations in terms of return on investment. And so there's a lot of education and presentations that are needed right now to bring them up to speed on terms of understanding game-based technologies and then doing pilot projects to where they actually believe in the technology, doing evaluation and validation to then start using it more broadly and then accepting it and implementing it across their enterprises. And actually, I've been into quite a few presentations where game is still a four-letter word in the energy industry, depending on who you're talking to. So as an example, for the nuclear industry, there are some factors that are actually driving and mandating the change over to game-based training. One is the retiring workforce. They're expecting half the workforce to retire in the next 5+ years. And you have the new upcoming workforce, which is the digital natives, and they're not going to look at a 3-inch binder and go through all that material to do their operations and training. And one of the key driving factors is in the new nuclear power plants, because now they'll actually have access to the CAD 3D files, and they can build in the virtual worlds aspect into the life cycle and the design aspects. So it's not a complete overhead expense. So I'll go ahead and hand over the presentation to Williams here for Total.
Thanks, Mike. Good morning. Good morning. First, I wanted to explain a little bit who is Total, because I don't think so people know Total in the USA. Total is an oil and gas company, and in fact an integrated oil and gas company. So we are finding oil and gas, so it's an exploration part, up to distribution, so with petrol stations and refinery through lubricant. Just for you, Total is the 5th largest oil and gas company worldwide, fully integrated, with some key figures. So we are closer to 100,000 people across the world with 130 countries, so it's quite large companies. And this kind of industry is quite difficult, and as you can see, some figure here, we put a lot of money in research and development part, just in order to help us to find more easily oil and gas and safely. So first of all, I would like to explain where and how we created the virtual reality training sessions. First, you have to understand now we are drilling oil under very high deep water. So the classic platform doesn't work now anymore. So we have to use new technologies in order to find and retrieve oil or gas. So this is a new kind of object, babies, if we want to say that. It's a facility where you've got nearly all processes in one boat, a small one, 325 meter long, 80 meter high, so it's quite a large systems, but very, very complicated. And so very complicated as a process point of view, but for the human operator too, it's quite complex. And the key word for Total is safety, safety, safety. So it means we have to find a way to improve the knowledge of operator in order to work safely. So the target of the training was to find a way how to improve the startup of this kind of machine. It's not like your car, you not just press the button start. That doesn't work. So it's much more complicated. So we have to find a way to improve this process, to reduce it, and to, in order to be sure it will be not any problem at this stage. So we train operator, but the idea was to train the operator before, in fact, the ship was completely built. So in fact, we trained the people 6 months before the delivery of the object. So it was improved a lot, this process. And at the same time, because it was the first time we had this kind of solutions to create, we was in face of a lot of problem issue with the 3D model. In fact, we reuse the 3D model of the engineering phase, but as you can see, it's quite a large system because there is something like 3,500,000 3D objects on the system, and a billion of the triangle to absorb in the simulator. So a lot of challenges at this point of view. Please, if you can just. So this is a small movie of how we set up the training sessions. And the first part of the training was just to learn where are located equipment. So this is here an overview of the simulator. So what you can see here is all the objects are inside the simulator. It's not only a part of it, it's all the system. And why we did that is because in this case, you can at any time have zoom in, zoom out of the facilities in order to understand better the context of the operation. So you get an avatar. So each trainee's got his own avatar, and you can work inside the model in order to find location of the systems. What is very important again here is multiple users, so you can have handling solutions with multiple systems. Please, if you can click again. Yeah. But what we find interesting in this project is not only use the 3Ds as a static model, but to find a way how we can add a lot of information for the trainees in order to for him to understand better the element. So just here, you walk in front of a pump, a valve, just click with your finger on the monitors, and you obtain information linked with this equipment. So it's another manner to track and to retrieve information through the 3D. So in this case, the 3D model starts to be a menu if you want, but very easy to understand for all operators. So you can have a PNID, so logical diagram of installation and something like that, just as it's here. So what we learn from that, in fact, is virtual reality system is easy to use from the trainee's point of view, and very powerful tool for the trainers and the management to say that it's a good way to train people. But now where we face is a problem with link with the 3D models. As I said before, there is more than 3 million of objects, and how we can have to be sure the information is relevant inside. That is some issue at this time. So as conclusions is it was a very success story, and we can prove now that accelerate really the startup, and we have zero default as a startup. So for this kind of object, it's very important to start safely and on time. And these demonstrations explain and started to explain what is the benefits of the 3D. For us, it's now plant life cycle management, so training is a good part. And it's so good. We already done the second one, so it's already done, and the training is at the moment in Angola. And we decided at the top management level to now use this kind of technology for all new projects. And just for you, we got something like 5 or 6 new projects every year. So it's quite important for us. So it's a contribution. Thanks a lot.
Next, we'll have Ray Rice from Heartwood.
Good morning. Heartwood 3D, we've been in and around 3D technology since 2002. We're located in the heart of Silicon Valley. As you folks know, that's home to innovation, success, and many of the world's largest technology companies. And in 2011, energy supplier Sochi, they wanted to develop interactive applications of their solar thermal energy collectors. So the project was a interactive learning app. Would you distribute it? This gentleman's going to pass around a sample of the Sochi app. And what they wanted was a 3D interactive learning application that instructs the assembly process of their SOPA Helios, if I can get that out, micro CSP collector, complete with virtual tools and 360 degrees of interactivity, designed to speed the learning process and improve retention rates. The technicians virtually build complex solar power systems and reconfigure them on the fly in the field. The Helios 3D interactive training application has proven to be an example of how mobile technology can be used to make learning more engaging and more effective. They were also able to reduce component damage during installs, and they were able to train, they were able to reduce tons of hours, trim tons of hours off of the initial install. And this, of course, this screenshot is, again, the gentleman has the actual learning application, but this is a screenshot of the solar collector. At the bottom, you'll see there's menus where the user, the maintainer, they're allowed to select specific tools. If you wanted to get additional information on those tools, specifications, vendor code information, with this application, we really had an open canvas. And we're really able to, not just with this application, but with this technology, we're really able to create almost anything that you can think of in and around maintenance training. This is Sochi, by the way. They are located in, they're based in Hawaii. But this is just a list of some of the folks that we've worked with since our inception. And these are some of the awards that we've received. The CP Apple logo there, we've got a great relationship with Apple. When they are pitching iPhones and iPads to their enterprise customers, when they want to show the full functionality and capability of mobile devices, they're actually using applications, demo applications like the Sochi to, again, show their customers the full functionality of application. Unity, of course, that application was developed on the Unity platform. Unity is located in San Francisco as well. We are strategically just 10 minutes away. We have a pretty good relationship with the folks there. The Google logo, being that the world's shifting to distributed learning and mobile apps, we were instrumental in building an application for Google's native client. Again, mobile apps, of course, it will have to be delivered via the browser. So this wave, if you will, of distributed training, blended learning solutions, this is just the beginning. You're going to see and learn more about how mobile apps and these types of technologies will change the way maintainers learn, repair, and assemble equipment in the field. If you have specific questions on the application or about the technology, of course we're going to do Q&A afterwards, but if you want other samples, links, if you want to test them on any of your iPad or any other device, just to get a hold of me and I can send you apps that you can play around with.
And so for GSE Systems, we have a unique strength in that GSE Systems Corporate has 40 years of experience in doing civilian nuclear control room simulators, operating training simulators. I actually did some of the very first ones for the nuclear industry. The 3D team within GSE Systems has over 20 years of experience in using 3D technologies. Actually, I was using Stereo 3D back when the crystallized glasses were $5,000 a pair. And so we've been able to integrate that so we can build a virtual environment and tie that to the simulation model, which then allows us to extend the value of the control room simulator to the engineering spaces. So if you already have a control room simulator for operator training, we can then have the virtual equipment in the field respond exactly as it would in the real world. GSE has, over the 40 years, has a wide expanse of clientele. This is a summary of some of our current applications that we've done in the last 2 years. In the upper left-hand corner is what we call glass models, where we make the invisible visible. So for, say, the steam generators or the reactor core, we're actually able to visualize in real time the data of temperature, pressure, flow rates of what's going on inside the reactor. So we give a real tangible visualization of what's happening rather than just looking at an instrument or control giving you a numerical value. You can actually rotate, look around at a certain spot and take measurement readings along anywhere within the 3D scene. In the upper right-hand corner is what we call our virtual flow loop trainer. So it's a training facility on how to deal with pumps and cavitation and flow and different types of pumping fluids. And the real facility that it was based upon is based on a nuclear power plant. They spent over $1 million to build the building. All of the equipment was actually used from a decommissioned plant, so it would have been several million to build the training facility. And what we've done is then built a virtual version of it that works exactly the way the physical one does. So if you close an upstream valve to a pump, you're going to cause cavitation in that pump. We trend the data, we track all of the information, and then you can actually do team-based or individual-based operations training. In the lower left corner is our task-based trainer. And so we've worked with EPRI, the Electric Power Research Institute, to do task-based training. Runs on that. We can run on Android, iPad, any of the tablets, as well as a PC and the web. Just like Heartwood, we're basically using Unity 3D right now. That's our game engine of choice, mostly due to the licensing structure, because the projects that we're doing in the energy industry to a large extent, it's hard to justify the licensing structure of using a higher-end Crytek or Unreal game engine. Although for some of the full-scale projects we have down the road, we'll be looking into those. And in the past, under previous companies, my team has used both game engines. And then in the middle is actually diagnostics, where it's the nuclear rod control cabinet. And if you make a mistake in that cabinet, you'll trip the power plant. Well, that's a $1.5 million mistake per day, and it takes 3 days to bring the plant back up. So you make a mistake, that's $5 million. So what we did is actually worked with Westinghouse on a joint project to build a virtual circuit board with all of the analog circuitry simulated. And then we have a virtual voltmeter and oscilloscope. And so you can take diagnostics of the circuit board and have the instructor insert faults and do a root cause analysis. And where that gets interesting is where you have multiple cards communicating to each other, where one card can give a false positive to another card, and you don't know which card is actually causing the source error message. And so the goal of this is the training, the way it's currently done is there's large tractor trailers with the hardware in it that travel from plant to plant. But the logistics means you can't transport it for international customers. It's costly to move it around and have it on site. And so by having it be virtual, you can actually use site-specific customized versions of those cabinets. So on the screen, there's the tablet version of the air-operated valve. And so this was the first application we did for EPRI. Since then, we've done 3 more add-ons, and we have 3 more products in development with EPRI. EPRI is basically a research and development group within the nuclear industry, or actually across the energy industry. But in specific, it was built along with INPO for training. And so all of the organizations that are members of EPRI get all of the research that's done out of it for free for their membership. So this application is actually available to anybody who's an EPRI member by loading up the application document number there by logging in. So the lesson here is task-based training of removal of the actuator from the valve, taking it apart, inspecting it, reassembling it, bench setting it, reinstalling it, so all of the procedures from start to finish. It's about 4 hours of training content, and they didn't have any 3D files for the actuator of the valve, so we reverse engineered it from photographs only. So we're actually built CAD accurate models for the photographs. Based upon our experience, we've been able to do that over the past 10, 15 years using some techniques we've developed. That's an image of the flow loop trainer, and so it's the goal is to provide a life-size, real-time experience, an immersive experience. And we have multiple windows that can come up in picture-in-picture, interactive picture-in-picture, so that you can actually have the switch in the control room in that lower right-hand corner and turn on and off that pump that's right next to you. And it's stereo surround sound. All the sounds are spatially correct, so as you walk up to a pump that's cavitating, you'll hear it, the volumes get louder. And so it's basically a fully functioning virtual facility. On the rod control cabinet that I was talking about, the Westinghouse, we first built the 3D model, a static model of the rod control cabinet, once again using photographs only of all of the components inside that back plane. And then we did more detailed work on the circuit boards. And so every circuit has its metadata tied to it. So just by placing your mouse over it, you'll get the actual specifications of that circuit. And Westinghouse gave us 2 data inputs and 2 data outputs from the circuit board, and nothing, and just the schematic. And we had to prove that we could do an analog simulation of that circuit board that was fully functional. So you can see, if you look to the right, there's the extender board, and you can see the red and black leads where the voltmeter would be attached. And so all of those points are testable points. And we were able to prove that all of the variables were accurate within normal operating procedures based upon that. So we're now expanding that to the other circuit boards and other control panels within the system. And then if you were by the booths, we have the 3DI touch wall. And that was designed for another project with Westinghouse that we're working with right now, doing some proof of concepts. Similar to what Total is doing, where they have the CAD files for the large, huge facility. Westinghouse has the AP1000, the new nuclear power plant. The problem is they need to have operators certified by the NRC 18 months before they can put nuclear fuel in the reactor. And job performance measures typically are done by walking through the plant and role-playing the scenario while the NRC checks boxes and takes notes as to whether you did the procedure right. So how do you do a job performance measure in a building that's under construction and not functional yet? So we actually have presented to the NRC, and they've accepted the idea of using a virtual environment as the foundation for a preliminary approval for the operators, and that will be sufficient for then the utility to be able to put reactor fuel in on time. Because any delay right now, training is on the critical path for the new reactors in Southern Energy's Vogels 3 and 4. So every day that power plant doesn't start up, if it's delayed, is $1.5 million that they're losing. Also in the presentation, towards the end, there's some additional slides that have links to videos and some other materials. So at this point, we'd like to open up to any questions you may have for any of us. Yes, sir.
Mike, I have the same question for you and for Williams. Since this is a sea change, in training for this industry, how difficult was it to convince the leadership that this represents something and an ROI can advantage?
Right. One thing that I found is with a first-time new customer that's never dealt with dealing with game-based technology as a media type, is really using a pilot project, something that's small in scale, 2 to 3 month turnaround, but something that either is a problem area in terms of training in that it rarely happens, but when it happens, it's catastrophic, or it's a problem that's very easy to fix, but happens broadly and happens frequently. So if you try to solve one of those two problems. The other thing is in that pilot project, try to do 2 types of experiences. One that is very broad, like a familiarization, like being able to walk through a plant and get familiar with where pieces of equipment are, so that you can see how broad the environment can be. And the other is something that's very narrow but very deep, like doing actually a task procedure, taking something apart and putting it together and getting down to where no 2 parts touch. And by doing that, then you can show management that if we budgeted more, we can have more lessons, or we can have more content. And that's been the way that, at least for us, is how we've addressed that issue. And once you have the pilot projects, then they can see the results of that and scale that up to where they can do the ROI on a larger scale.
Yes, from total point of view, in fact, a little bit different. In companies like us, so the process is quite old, and we have a training part, a theory part with PowerPoint presentations, and after a practice on the field. And people say that we don't want to lose the fact we're going to practice on the field itself. So we had to convince the management, in fact, this kind of technologies is behind the theory and a practice on field. So it's why we did the first one on these large facilities, just to demonstrate that is working. But at the beginning it was difficult because, like I say, there is four letters, game, and everybody at the management point of view said, it's a game. What are you doing with the game? So we have to explain through these demonstrations. It's not a game now anymore. It's a virtual world. It's a fact you are in nearly the same situation as if you are outside in front of the machine. So it was the fact how we demonstrate the good things of this virtual reality system by doing this pilot, not a proof of concept. It was really a pilot. Some difficulties.
Can I ask a follow-up question to you? What platform did you use to develop yours? I gleaned that Unity is the platform of choice for
this. We use a wide variety. Typically, we try to pick the game engine based upon the needs analysis of the training, the visualization, the simulation. We try to do a lot of our programming outside the game engine so that if you want to change down the road, you're not hooked into any one. In his case, we're dealing with $1 billion bonds.
Yeah. In fact, the problem we have is, again, it's easy to do a training session if you do a part only of the system. We didn't want to do that, so we said we want to have the full vessel represented in 3Ds. Again, I explain this because we want to have at any time the possibility to have a zoom, or at any time have the possibility to go on another part of the boat. So it was a big challenge at the IT point of view. We didn't find any applications except one, and it's VR context solutions, now bought by Siemens. Now it's a Siemens company, part of the company. It's the only system I found capable to retrieve this kind of full systems. Okay. We started the first sessions we did with a small proof of concept in a refinery, not in a FPSO like that. It was done with Crytek, the CryEngine. CryEngine is very powerful. The only issue we had to do that with CryEngine is the number of triangles. At this level, it was 2 years ago, and previous CryEngine system didn't handle the number of triangles. But again, just to add to Mike's remarks, we are waiting for new solutions, maybe more generic solutions. Unity, I'm not sure if it's capable to do that. I don't know.
I'm sorry to ask. I have a follow-up question. Has anybody explored Open Simulator? The Open Simulator platform?
We have in the past. So my team formerly was part of 3D Solve, which was acquired by Lockheed Martin, and then that kind of was reorganized. And so we did back then, as part of GSE, we haven't had a need to work with OpenSim in the last couple of years, but we certainly would be open to it.
It's just, it's made rapid strides. Vivox Voice was added to it a couple years ago, and now the Bullet Sim, the new physics engine, is just about to be added. So, it's open. It's not like I'm selling it. It's just I use it. So I was just curious if there were. You mentioned the sweet spot being Unity versus, a more expensive platform, and I was curious if you went the other way as well for certain applications, to the...
Just a remark about the fact you said it's quite expensive. It's not really expensive. The solution we got here is not quite expensive. We developed this simulator in 3 months' time. Okay? Just a remark. We had the 3D model before, okay? So the 3D model is coming from the engineering part. So 3D model is already existing.
Yes.
From this point up to the sessions here, 3 months of work. And the cost is not very expensive, so we don't care.
To some extent, just the licensing fees to have access to the game engine. So it's proportional to the scale of the project. If you're doing a small project.
Yeah. For that, it's not a game. The VR context is not a game system. It's not a game engine. It's a proprietary engine. The 3D engine is a proprietary. It's not a game engine.
Thank you.
Any other questions? All right, thank you for coming today. Obviously, our contact information is in the PowerPoints, and the PDF will be available online. And feel free to contact us at any time regarding the projects that were presented today. Thank you.
Sing a little song for us about his predictions of the future. Aaron Silvers, I'm sorry.